Hello everyone, so I wanted to share the, experiment with this machine. Well, long story short, I had a machine for making PCBs. I did it at the old house and it didn't work very well, so I left it there, basically as a trash. And this is supposed to be improvement because listen, this looks like a simple thing, right? Just copper chloride goes through like this part with a lot of holes and it etches the PCB, but it is not that simple. The first thing that gets you is the water. I don't have any great example, but look at what this water does. Especially this part on the bottom. What you can do is decrease the angle, and this problem starts to behave a little bit differently, but still it is not great, and this is because a lot of surfaces, mainly plastic, are not very hydrophilic. Even though hydrophilic is not the best word, I bought this tile for my bathroom and I had some leftovers, and I noticed in the bathroom that this wicks water, literally, you put one drop here, let's try to do that, and it truly wicks the water. And so I thought, okay, let's try to use this and also try different set of angles, and I have made this in such a way that I can do that with this screw here, so I can pretty much just remove it, set it to different height, and I've got different set of angles. And the question is, will the angle of this thing influence the speed by which PCB will get etched? Because it's great to have a machine, but you don't want to wait 10 hours to get one reasonable size PCB etched. So the build of this thing is rather simplistic. I have made a wooden frame very quickly, and these tiles are basically glued together with CA glue, so you can expect this to start leaking, I guess, maybe. But I want to test the concept. In the back you can see cheap Chinese pump that can withstand acids, and in the front, I guess this is best way, you can see that I glued these two PCBs, drilled a hole through the tile, put some little tiny bit holes there, like this one. And originally I had different ideas, to connect it to special container, but then I realized, well, it wouldn't work the way I want. And also this PCB here, this is done in order to put PCB against it, pretty much. That's well, there's a little more reason for that, but I will explain later. And I forgot to mention, this is just cheap PVC tube, also glued with CA glue, and I bent it by heating it and stuff like that. It is pretty easy. There's a series of holes drilled into this. They are small. Obviously these two holes, they are same diameter, but so these two holes put out most amount of liquid. I kinda hoped that with enough pressure the resistance of the transition between flow between these two diameters would be dominant, but I don't have enough pressure, obviously, and you don't really want high pressure, so it's me being stupid mostly and not having drills stepped up by 0.1 millimeter diameter. But anyway, you may ask why I have used this kind of design, and I guess good question is, what kind of designs are there? One kind of simple design is to have a container, just some servo motor or something like that, and produce rocking motion like this, which agitates the liquid. But with sizes like this it can get tricky. Even with this small container, if you hit resonance you will get spillage, and you can tune it so it does not do that. But if you look at this, the PCB travels in there, and it is I'm not sure, and it will be probably much slower than this. Then in industry they use spraying machines, but obviously you don't want to do that indoors, even if you like enclose the thing. Like it would be bulky and horrible. I guess this rocker thingy can be like least amount of, like it would be most compact, I guess. With spraying you get the most consistent etching across the surface, I guess. With this machine the etching starts here and slowly progresses down, basically. And maybe you could engineer some kind of tunnel where this is PCB and the liquid flows here, and this is like narrowing. Basically, if you plot the flow rate over the surface, you would get graph something like I don't know, starts from here, it will slowly go down and then probably plateaus out because, well, surface tension and stuff like that. And basically the idea could be that the PCB will be fully immersed, so there will be no fumes and you would get consistent etching, because basically this atom of copper sees like I don't know, 4 times more copper chloride molecules than an atom here, and basically, so yeah. Anyway, I forgot to mention one exciting technology which is pretty much new. There is this one guy on YouTube and he is experimenting with using I think it's diode laser to pretty much lithography and etching process and just directly ablate away the copper from the PCB. And what you can then do is use solder mask and ablate the solder mask from the PCB. So you can do pretty much whole PCB with laser. It would be cool if you can then put components in and use laser to solder them as well. Well, there is one big complication, as with all systems. The copper chloride tank. See, I have not done anything fancy here, I have just this tank. You want it to be covered, definitely, and ideally like fully sealed with some drainage port. Well, my plan is to order a box for electronics that is like hermetically sealed to the environment, at least, like, well, hermetically, you know how it is. Anyway, so I will put this in and hopefully this won't cause too much mess, which is almost inevitable, but you know, it's fine. This is prototyping, I guess. I guess I will start here, which is roughly 11 degrees. Okay, so how am I going to find out the optimal angle? I guess I have made few like targets like this. They are pretty much, I guess, consistent. Let me, I guess, show you something. Let me put bigger PCB here and start this machine, and so you can see how this operates, I guess. So first of all, you can see that while this material of the tile is wicking very well, the PCB itself is not. This is not a big deal. Normally you can like force it like this and then it will pretty much remain submerged, ideally. There are more issues. For example, the flow of the liquid can like lift the PCB up, and like here you can see this is not submerged, for example, and now it seems to be happy. So what can you do? You can increase the flow, I guess, and maybe you can prevent creating like hotspots. In previous machine I did put a piece of cloth in front of this like nozzle, I guess you can call it. I've modified this one a little bit with soldering iron. I tried to push the holes, close them a little bit, and it worked, maybe a little bit too much, so there's that. But this is, I would say this is fine. And there's one more thing I want to bring to your attention. As you can see here, there is definitely some kind of front of the liquid where it changes velocity, and because of that it is deformed. And what this looks like in practice, it looks like its height profile would be like so. So these edges gets less like flow of the liquid than the front, like it's first like millimeter, let's say. You can also work around it. Well, the simplest thing would be to cut PCB about 1 centimeter longer on each side, basically. Alternatively, you can put another PCB, like a blank, in front of this one and maybe to the sides. And finally, as I was talking about the closed container, you can see already, because this thing is sucking air, it is producing bubbles, and bubbles produce a bunch of spraying. So I can pretty much tell you that after like 2 hours this tile will be completely wet and saturated with copper chloride, and this wood will be green after few days of use pretty much. Let me test first PCB. I guess I can put it right here, and that's interesting. I guess I could have that wouldn't help. After this I will be lowering the angle by, let's say, I don't know, 3 degrees, and there will be another thing that will happen. This hole maybe won't be able to drain as much liquid as it can now, and overall the flow will stop, it will like slow down. So there will be like some kind of secondary front that will be like in front of this edge of the PCB, in which the PCB under the etching will be like completely submerged. And so I want to measure basically if having PCB up here, down here and down here has any different etching time. And so after this one is done, maybe we'll see it, and maybe it will be at a much lower angle. Alrighty. So the etching is nearly done, and this is how it looks like, and this is how much time it took. It's obviously time just for reference, like this solution is not very concentrated and the temperature is quite low here, so this can be much faster. And obviously after you etch like 50% of the board, you would flip it around, so it would be faster still. So as I said, the bottom corners are very slow to etch because of how the liquid flows. Alrighty, so this is a new sample. I've added a drop of acid and peroxide, so this thing is fresh. So it is as fair as it can be, even though it really can't be. But yeah, let's see what this does. The angle is 9.7 degrees or something like that, and I had to put this piece over it because it struggled to stay submerged completely. So, but this should not influence the speed whatsoever. Well, this did etch a little bit differently than I would expect, but it's fine, I would say. Also, time is very good. Now, I'm not sure what's going on with this smudge here. In spirit of previous experiment, I will consider this done because I don't want to wait. And the time is, let's say, 25 minutes, 28, something like that. Okay, this is now 6 degrees. Alrighty, we are pretty much done with this, and focus. And so this one on the top was slower than this one on the bottom, which is not what I expected, but it is what I need to know. And I forgot the time, it's 30 minutes. So it's interesting actually. So it is slower than before, and I smell HCl fumes in the room. So is it the angle? Looks like it is. Let me try again. The initial angle, I think it was 11 degrees, something like that. So we'll do that and see what happens. So this is the new setup, and to gather more data I have this one basically with some flow correcting piece on the top. It is a little bit deformed, this has a little bit of smudge there, but anyway, I will run this and see what happens, I guess. I'm a bit too late, but it seems that this one has etched faster than this one, completely at least, by a very small margin though. The time is like 25 minutes or something like that, so yeah, alright, so overall I'm happy with this angle. One thing that I need to do is find some kind of plug that prevents this making noises and sucking in air. This PCB, which is like a spacer pretty much, is being submerged for, well, I don't know, maybe 3-4 hours now, maybe even 5. And so it would be nice to check how much is you know what I mean, how much is over etched or under etched, I guess you could say, because there is mask on top. So at least on these thin lines there is definitely some pitting here. Yeah, probably not going to show it with this amount of light, but yeah, we'll use macro lens for that. Alrighty, so this is not perfect alignment, but you can definitely see that there is some under etching, and it's probably even quite significant, I would say. For the time it was going on, it's not that bad actually, and here it is pretty much fine. Like on this spot in the center of the screen, like it looks smaller, but I would say that it's fine. I actually experimented with one more etching method. It was like spraying while the PCB was submerged. So there were like, I don't know, 50 nozzles, and with very thin lines you could see like the circles of the under-etched areas where the nozzles were. So like the etch time was like 8 minutes, sure, that was pretty good, but the under-etching was very non-uniform. Here it is quite uniform, I would say. Okay, here you can see some pitting, but this is the property of the mask itself, so there is not much you can do about that. Anyway, that's about it, so see you next time.